Before I start talking about my study, I would like to thank a few people that helped make the study possible. First, I would like to thank my partner, Mike Davis, and my thesis advisors, Dr. Justin Furman and Dr. Charlie Schweik. I would also like to thank the CFUN, the ICONS program, and UMass Amherst for funding this study and providing support. My study is on the neurobehavioral perspective on increasing water conservation behaviors through shower timer devices. So why is water conservation important? This map indicates the future of water. The red area indicates the regions that are getting drier, whereas the blue regions are the regions that are getting wetter. Since this experiment focuses on water conservation, the regions in the dark red coloring should be noted. Water conservation does not provide solutions to problems related to water scarcity, but increased water conservation behaviors can increase awareness around the problems that water scarcity creates. This graph contains data from a 2014 study. The dashed line indicates accurate water use estimation, whereas the solid line indicates participants' estimation of water use. As you can see, the larger amount of water a certain activity uses, the more inaccurate the participants' estimations are. This data indicates that there is a fundamental lack of knowledge around water usage in the public. To extend this line of thought, many studies indicate that individual behaviors correspond with overall water usage. What are everyday examples of behavioral change? Suppose a student got a bad grade on an exam. If they want to get a better grade on their next exam, they would have to reflect on what they did wrong and implement the necessary changes to get a better grade. Studies have indicated that individuals who have technology such as water metering devices that are informing them about their water usage are more likely to have more behavior corresponding to water conservation. Alternatively, individuals who do not have any devices, such as the water metering devices, are not going to have a high level of water-conscious behavior since they are not getting accurate information about their water consumption practices. So from this research, we decided that the aim of our study was to find to what extent does individualized and targeted information increase one's water conservation behaviors. As I've mentioned before, I'll be analyzing this study through the neurobehavioral perspective. But what does the neurobehavioral perspective mean? This term can be defined as a focus on how the brain affects emotion, behavior, and learning. In this study, I want to find which intervention method facilitates the greatest behavioral change to encourage conservation behaviors in the average person. I also hypothesized that there will be a graded effectiveness where the active intervention produced the most behavioral change, followed by the passive intervention in control. My partner Meg Davis will explain the data that we got from our pilot study from 2018.
Looking at the distribution of our data, you can see a shift between the control group and the active intervention group. Before intervention, the mean shower duration was just over 12 minutes, and after intervention, the mean shower duration was 7 minutes and 13 seconds. We found a significant difference of almost 5 minutes between the two groups, which is about a 40% reduction in shower duration.
Our original plan was to put the shower timer devices in the residence halls, but COVID made us modify these plans. We recruited participants instead, allowing us to complete our research remotely. There are 3 different groups in our current methodology, including the control group, passive intervention, and active intervention. We anticipated 30 participants with 10 participants in each group. The control group has a non-interactive device with no direct information about water conservation. Passive intervention has a poster about water conservation and a non-interactive device. The active intervention has an interactive device. This device displays shower duration and approximate water consumption. The devices were assigned to each participant randomly, and the data was sent anonymously. In actuality, we ended up with 9 participants in total. There were 3 participants in the control with a total of 40 data points, 4 participants in the passive intervention with a total of 70 data points, and participants in the active intervention with 96 data points. My partner, Meg Davis, will talk about the active and passive intervention.
We created 2 intervention methods, the first being a passive intervention poster on the left, and this mimics the original posters from UMass that were placed in the residence halls. and we developed an active intervention device, which is on the right, and it's a modification and improvement from our original water timer, and it provides live feedback to the user, showing shower duration on the top and water consumption in that time on the bottom.
The normalized histogram indicates that the passive intervention is skewed to the right compared to the active intervention, indicating that the passive intervention had a greater frequency of shorter shower times than the active intervention. The control mimics the trend of the passive intervention, but it is to a lesser degree. The t-tests indicate that there's a significant difference between the control and passive group and the passive and active group. There is no significant difference between the control and active group. This graph contains the accumulation of the data in the control group. The passive intervention and the active intervention graphs will be set up in the same way. The x-axis contains the days that the data was received, whereas the y-axis contains the shower time in minutes. The individual points indicate individual shower times, and the light pink line is the average of the shower times in that given day. The dashed line is the line of best fit. This graph indicates that the presence of the non-interactive device in the showers had relatively little impact on the time the participants spend in their shower. Since the passive intervention graph has a negative slope, this graph indicates that the presence of the poster and the non-interactive device over a period of time helped to decrease the amount of time the participants spend in their shower. Interestingly, the active intervention device had a relatively flat slope, which indicates that the presence of the interactive device during this time frame did not drastically change the overall time that the participants spent in their shower. Our aim was to find if targeted and individualized information increased one's water conservation behaviors, and we found that targeted and individualized information was not necessary to produce water conservation behaviors. The data indicates that the passive intervention encouraged participants to take shorter showers when compared to the active intervention. The negative slope in the passive intervention can be interpreted as the participants decreasing their overall water usage as their time with the intervention increases. My individual hypothesis is incorrect since the degree of effectiveness from the least to the greatest is the control, active intervention, and passive intervention. Possible limitations of the study include sample size, device malfunction, amount of data collected, and the time of data collection. Future directions include working on the original study with the devices in the dorms, working on device durability and its ability to upload data. Societal implications based on this study include the ideal placement of reminders regarding water usage can produce more water conservation behaviors. In this case, a simple reminder can provide motivation to an individual to set a new goal to conserve water. Each time the reminder is brought to the individual's attention, it is plausible to conclude that their motivation to meet their goal is sustained. Implementing this and possibly broadening this to an information campaign focusing on consumer water use can bring into light the detrimental effects of water scarcity. How can you implement this information in your daily life? Putting simple reminders around area where you use water, such as showers and faucets, can impact your overall water usage. I hope you found this video informational. For more information, here are a few links.